So in the last lecture, we were discussing about association rules and the types of association rules. And we had discussed that there are two algorithms that can be used for finding these association rules. One is the Apriori algorithm and the other one is the FP growth algorithm. So we'll be seeing what Apriori algorithm does and how does this algorithm help you find association rules. We'll begin by first understanding what does this algorithm work upon. So there's one basic principle that this algorithm works upon, which is called the a priori property. This property says that if a set A of items is not a frequent item set, even if you add up anything inside that set, or you say that the union of this set with anything else cannot be a frequent item set. So for example, if I say that bread and butter are not my frequently purchased items, I definitely will not be able to say that bread, butter and cream are frequently purchased items, because bread and butter at the first place themselves are not frequently purchased. And we are not talking about an item, we are talking about an item set, which is a combination of items. Okay. So this algorithm basically has two steps on which it is based. One is called the joining step and the other one is called the pruning step. What are these steps exactly? That we'll be seeing when we solve the example. So let's take the first example here. As you can see, this is T1, T2, T3, T4, T5. You see numbers, rather digits mentioned here. So T1 has got 1, 2, 3, 5. T2 has got 2, 3, 5. T3 has got 1, 2, 3. T4 has 1 and 3. T5 has 1, 2, 3, 4 and 5. Now this 1, 2, 3, 4 and 5 can be 5 different objects, say A, B, C, D, E. Or I can say an umbrella, a comb, a shampoo, say a conditioner, and say bread. All right, random 5 items. But I am denoting these in the form of numbers. Okay. So if you remember, we talked about support and confidence. So there's this support and confidence percentage given to us. Okay. So what you do is the first step that you have to perform in this algorithm is that you have to find out the count for support. You see the support 80% mentioned here. What you first do is that 80% has to be converted into a number. So do you see that there are 5 transactions here, T1 to T5? 80% of this 5 gives you the support count. So 80% of 5 is going to be 4. So the support count for this question is going to be 4. Okay. Here comes the first iteration. What you do is you initially have to take a count of unique items. By unique items, I mean that in this entire data set, how many unique items are there? You can see there are 5 unique items, namely 1, 2, 3, 4, and 5. What you do here is you write down these items 1, 2, 3, 4, and 5, and you start counting how many transactions contain these items. Say for 1, we have 1, 2, 3, and 4. For 2, we have 1, 2, 3, and 4. For 3, we have 1, 2, 3. For 4, for 3, we have 1, 2, 3, 4, and 5. For 4, we have only 1. For 5, we've got 1, 2, and 3. So that's what I've done. I've taken a count here. Now remember, if this transaction 5 was 1, 2, 3, 4, 5, 1, which means there were 2 ones in that transaction, doesn't mean that the count of 1 is going to be 5. We only have to count the number of transactions containing that item. Not how many times the item is present, but how many transactions contain the item. So this is the count that has been taken initially. This is called your candidate set. Now comes the step of pruning. You found out the support count was 4. So all the items that have a support count less than 4, not equal to less than, but only less than. So less than 4 will all be pruned. So 4 and 5 get pruned because they have support count 1 and 3. Okay, so we are left with 1, 2, and 3. So you write down L1 as 1, 2, 3 with their counts. This is your frequent item set in iteration number 1 after performing the pruning step. Now comes step number 2, that's join. As I said that the entire algorithm is going to be about pruning and joining. Okay. So here comes the second iteration. What you do is initially you have to create, since this is iteration 2, the item set is going to have 2 items. Here each item set had got only 1 item. Here there are going to be 2 items. So what you do is out of these frequently mined items 1, 2, and 3, you have to form combinations of them. So the combinations will be 1, 2, 1, 3, and 2, 3. Okay. What next? You take a count of 1, 2. That how many transactions contain 1 and 2 both. So see, for 1, 2, it is going to be 1, 2, and 3. Okay. For 1, 3, it is going to be 1, 2, and 3. And for 2, 3, it is going to be 1, 2, 3, and 4. So that's what I've mentioned here. Again, the minimum support count was 4. We have to prune out the item sets that have got a count less than the minimum support count. So the minimum was 4. So that's why these two that have got a count 3 will be pruned. And we are left with 2, 3. This is frequent item set in iteration number 2. Okay. Because we have only one item set left, we are not going to try any other combinations, and we directly find out the rules that you can get from this frequent item set. So 2, 3 become your most frequently purchased items together, and now you find out rules. So one rule can be that 2 implies 3 and the other rule can be 3 implies 2. You can also read it as if 2 is purchased, 3 is also purchased, or if 3 is purchased, 2 is also purchased. Now see, there's a difference between the two because it is about dependency, whether 3 is dependent on 2 or 2 is dependent on 3. So that's why you have to try both the combinations. Okay. After you write down the rules, you have to find the confidence for each rule. Okay. How do you find out the confidence? Here is the formula for confidence. Say, for example, if a rule is A implies B, the confidence will be support count of AB together divided by the support count of LHS, which is A here multiplied by 100%. If we apply this rule here, support count of AB, which means 2, 3 is 4 divided by the support count of LHS, which means 2 here. Support count was 2 was 4. So 4 by 4 into 100 gives you 100% confidence. For the second rule, it is going to be 2, 3 is 4 and 3 was 5. So 4 by 5 into 100 gives you 80%. Since 180 both are greater than 70, which was given to you in the question, both these rules are approved and they are both accepted as your frequently mind pattern generated association rules. All right. I think one example will not be enough for better understanding. Let's just go to one more example that's a little longer, but this will help you clear all your doubts. Okay. So here is the item set. As you can see, there are 9 transactions shown here, and these are the respective items there. Again, the items here are 1, 2, 3, 4, and 5. Okay. So iteration 1, we start with iteration 1. Support count here has been given directly. So if this percentage mention, you have to find out the count, but if the count is given directly, there's no need of finding the count. Okay, so what we do is, first of all, you will list down all the unique items. I've done that, and you count their occurrences. So for 1, it is going to be 1, 2, 3, 4, 5, and 6. For 2, it is going to be 1, 2, 3, 4, 5, 6, and 7. For 3, it is going to be 1, 2, 3, 4, and 5, and 6. Yeah. For 4, it is going to be 1 and 2. And for 5, it is going to be 1 and 2. Okay. Since the support count is 2, anything less than 2 is going to be pruned out. Here, all of them get selected because none of them is less than 2. So your candidate set and your frequent item set are going to be the same. Coming to the next step, which is called your joining step. What we do is you try out all the combinations. So you say the combinations are going to be 1, 2, 1, 3, 1, 4, 1, 5, then 2, 3, 2, 4, 2, 5, then 3, 4, 3, 5, and then 4, 5. What we do is we take up count. How many times has 1, 2 appeared? So 1, 2, 3, and 4 times. 1, 3 is 1, 2, 3, and 4 times. 1, 4 appears only once. 1, 5 appears 1 and 2 times. 2, 3 appears 1, 2, 3, and 4 times. Similarly, you calculate it for 2, 4, 2, 5, 3, 4, 3, 5, and 4. So here is the count mentioned. What we next do is we prune out the item sets which have got a count less than 2. So you see 1, 0, and 1, 0. All 4 of them will be pruned out and we'll be left with these many. Okay. Now, since the last example, we only got one rule here, it was the conclusion for us, and that was the final item set selected. But now, since you've got a lot many rules, you will go to iteration number 3 and you will be trying join operation upon these. So how do you perform join? This is an important part here. For iteration number 3 candidate set, what you do is you have to find all the combinations. So to find out all these combinations, what you have to do is, see, here is 1, 2. You have to check whether 1, 2, and 1, 3 have got anything in common. 1, 2, and 1, 3 have got 1 in common. So you can write 1, 2, 3. Then 1, 2, and 1, 5. So 1, 2, 5 can be written. 1, 2, and 2 3, so we can write 1 2 3 is already there. 1 2 2 4, so we can write 1 2 4. 1 2 and 2 5, so we can write 1 2 5 already there. Okay, next is 1 3. So you check 1 3 and 1 5 have got 1 in common, so you can write 1 3 5 here. Then 1 3 and 2 3 have got 1 2 3 in common, so it is 1 2 3, which is already there. 1 3 and 2 4 have got nothing in common, so you don't take it. 1 3 and 2 5 have got nothing in common, so ignore it. Okay, coming to 1 5. 1 5 and 2 3 nothing in common. 1 5 and 2 4 nothing in common. 1 5 and 2 5 5 in common, so you write down 1 2 5, which is already there. Okay, now 2 3. So 2 3 and 2 4 have got 2 in common, so you can write 2 3 4. Then 2 3 and 2 5 have got 2 in common, so you can write 2 3 5. See, both of them have been written here. And then at the end, 2 4 and 2 5 have got 2 in common, so you write down 2 4 5. I hope that's understood. I'll repeat once again. 1 2 and 1 3 have got 1 in common, so you write 1 2 3 here. 1 2 and 1 5 got 1 in common, so you write 1 2 5. 1 2 and 2 3 got 1 2 3. 1 2 and 2 4 have got 2 in common, so 1 2 4. 1 2 and 2 5 got 1 in common, so 1 2 5. 2 in common, sorry. Okay, then you come to the second one, 1 3. So 1 3 and 1 5 gives you 1 3 5 here. 1 3 and 2 3, so 1 2 3. 1 3 and 2 4 nothing in common. 1 3 and 2 5 nothing in common. 1 5 2 3 nothing in common. 1 5 2 4 nothing in common. 1 5 2 5 5 in common, so you write 1 2 5 here. Each unique item has to be written only once, but then you have to check all the combinations. 2 3 with 2 4 2 in common, so 2 3 4. 2 3 with 2 5 2 in common, so 2 3 5. 2 4 and 2 5 2 in common, so 4 5. Okay, now again you take a count of them. How many times have 1 2 3 appeared together? I can see only 1 and 2. Okay, so 1 2 5 1 and 2. 1 3 5 only once. Then 1 2 4 you can see only once. 2 3 4 we can see none, 0. 2 3 5 we can see once, and 2 4 5 we cannot see, so 0. Okay, again the ones that have got a count less than 2 will be pruned out, and then we'll be left with only 1 2 3 and 1 2 5. Okay, now since we right now also have got two item sets, we're going to try another combination. So we go to iteration number 4, and you see in the third iteration there was only one item in common. Here there have to be two items in common, so 1 2 3 and 1 2 5, we've got 1 2 in common, so you write 1 2 3 and 5. Now 1 2 3 and 5, if you take a count here, it appears only once, which is less than the support, so you have to prune it out. Now since now we don't have any rule left, we go to the previous iteration, and the final rules in the previous iteration, which means these are your final rules selected. So here are my rules. I write 1 2 3 here and 1 2 5 here. Now, like in the previous question, we wrote 2 gives 3 and 3 gives 2. Here also we have to write, but now we've got 3 items in the item set. So how do you write it? 1 implies 2 3, 2 implies 1 3, 3 implies 1 2, and then the reverse of it. That 2 3 implies 1, 1 3 implies 2, and 1 2 implies 3. I'm repeating it for this one. 1 implies 2 5, 2 implies 1 5, 5 implies 1 2, and then the reverse. That 2 5 implies 1, 1 5 implies 2, and 1 2 implies 5. This is like bread implies butter and butter implies bread, which depends on the other, that ways. Okay, so again we'll have to now find out the confidence for each of them. What do we do? Formula for the confidence was support of all three together divided by support of LHS. So support of all three together, 1 2 3 is 2, divided by LHS, which means 1. 1 support was 6. So 2 by 6 into 100. That's going to give you the percentage of confidence. Similarly, for each of the rule, you have to find out the confidence, and all the rules that have got a confidence greater than 70, greater than equal to 70% will be selected, and rest of the rules will not be selected. So in the final answer, you have to write the rules that have been selected, showing this calculation. I leave this for you people to solve. I will be sending a question to you that you need to solve in an email. Follow it by the lecture. All right. Okay, I hope this is clear, guys. Thank you.